So hi everyone, my name is MINKO GECHEV, and I'm working on the Angular team at Google, where I'm leading the product roadmap pretty much, collecting feedback from developers and figuring out what we'll be working on. Today, in my presentation, I'm going to share with you what we shipped as part of Angular version 20 and where are we going to be taking the product from here on. The first part we're going to spend on version 20 for about 10 minutes, 10-15 minutes, and after that we're going to dig into the feature roadmap in the future. And since I'm a developer and also trying to figure out what we should be working on, I decided to model the process roughly with a JavaScript function. And here is what I came up with. It is an asynchronous function that we call recursively. So we improve Angular recursively by taking the current state of the world, seeing what is the current trend and what is the need of the developer, whether we need to focus on scalable applications or whether we need to focus on Gen AI. From there, we're improving the framework by composing changes in performance and developer experience. That's roughly what it looks like, and it is a recursive, iterative process. I've been involved in Angular for over 12 years now in different capacities. I started using AngularJS back in the day. I was building web apps with it. Later on, I was contributing to the framework in my spare time, doing community contributions. I joined the team as a contractor. After that, I joined as a Googler. And finally, now I'm trying to figure out how we should be developing the product to improve its developer experience in ergonomics. And it all started with this email right here. I just finished an internship, and I was wondering what I should be doing next. And someone commented on my blog asking me to build their web app for an iOS application that they had. So I started coding. I picked AngularJS specifically because it aligned really well with my core values to write maintainable and testable code. For 2 months, I created this application. It took me literally about 2 months, so I can after that take my finals in university. And that was my workstation right here. That was my work setup in my college, my university dorm room in Bulgaria. I wrote thousands of lines of code, and the project was overall a success. Well, the business didn't have market fit, so it didn't work out, but the application was out there. And even though this application doesn't exist today, I took all the learnings I had from AngularJS, and I collected them, compiled them in the first AngularJS style guide that I published on GitHub, and I got some traction. That was back in 2013, and now we're at 2025. That was even a different framework back then, AngularJS, that looked different and functioned differently. And today, we're at Angular version 20 that we released just around a month ago. So some of you probably know that the features that we develop for Angular, they go through like multiple processes, especially the larger ones. When we collect feedback that developers are seeing a gap in Angular, such as something in authoring experience or reactivity, we collect as many signals as we can from GitHub, conversations with developers, social media, and from there we built an experimental implementation. This is something like an evolutionary prototype that we're going to evolve from there. Once we build this prototype, we validate it with people. So we experiment with projects within Google. For example, that's what we did with Zoneless and Google Fonts. From there, we tune it, we improve it step by step, until it eventually reaches developer preview. When it reaches developer preview, it is no longer as experimental. We're pretty much confident in its implementation, but we're not ready yet to commit to ship it as stable, because we may want to do minor adjustments in the public API, and we would like to open the door to do that in a minor or a patch version even. Still, a lot of developers are already using this feature in production, and we collect even more feedback until we finally do the final polishing touches, and we graduate the feature to stable. So in Angular version 20, we spent a lot of time in these transitionary steps, specifically in polishing features from developer preview to stable. And some of my personal highlights are specifically around reactivity, debugging, and tooling, and developer experience that I'm going to share in the next few minutes. First, All the reactivity APIs that are fundamental for building Angular applications now are stable. We did some minor adjustments in the timing of the effect function, but it is now stable. It's a version 20. Same with linked signal and toSignal. We also introduced some experimental APIs that were the missing piece of our reactivity story around signal and asynchronous data management. We introduced the resource architectural pattern that allows you to respond to change in state with an asynchronous action. Here is how it roughly looks like. Here we declare a signal, the user ID, and we use it in the params, in the parameters of the resource. The parameters is just an object literal key value pairs. So the keys are the names, and the values are respectively signals. And whenever any of these signal changes, we invoke the asynchronous action right here. In this case, we're just sending a request over the network. And it seems a little bit verbose, and it is actually. This is an artificial example. I'm going to show you a significantly more compact example with resource in a little bit. This way, we can respond to state changes with asynchronous actions without leaving the signal space. Since we know that developers are building web apps, and it's very common for people to want to send requests over the network, we developed a special kind of resource called HTTP resource, which is a significantly more expressive API that allows you to send requests over the network with resource receiving signals as results. And here is how it looks. We have the user profile component. Inside of the user profile component, we declare an ID. And inside of the resource, we have a callback which returns the URL that we're going to send an HTTP GET request to. Once we do something that triggers an update in the user ID, we're going to resend this request. And there are some really helpful methods of the resource result, specifically around progress or is loading, which we can directly use in our template. And let's say in this case, use resource is loading to show a loading spinner whenever the request is still pending, and eventually render the user profile card. This is a very explicit data flow. We specifically looked at the space. We evaluated the suspense pattern in React. We evaluated a variety of different solutions in other frameworks, and we figured out that this might be the most obvious explicit data flow that enables you to handle asynchronous actions. We only scratched the surface with resource here. If you want to learn more about it, make sure you check Manfred's talk right after mine. He's going to dig deeper into this API and the functionalities there. So over the past couple of years, we doubled down our investment in server-side rendering as well. And some of the two major features that we shipped are route-level render modes and incremental hydration. With route-level render modes, now you can pick which individual routes in your application are going to be server-side rendered, pre-rendered, or client-side rendered. And for pre-rendered routes, we can even extract the parameters whenever we have parameterized routes so that we can pre-render individual pages. But a feature that I would like to stop on particularly is incremental hydration. Just out of curiosity, how many of you have heard about incremental hydration before? All right, so about 30%. Let me tell you roughly how it works. So with incremental hydration, we use it with server-side rendering. And whenever you send a request to the server, well, the server is going to render the page, right? From there, it is going to return HTML to the client. And the client is going to parse this HTML, render it, and start downloading the reference JavaScript. After that, this JavaScript needs to get executed. And finally, the application will be able to respond to user events. And this could be a long period of time, depending on how much JavaScript you have. Sometimes even users may start engaging with your application before the application has downloaded and executed all the JavaScript. So there will be this gap, interactivity gap. And the more JavaScript you have, the longer this gap is. So what you can do is just download less JavaScript. But if you're using traditional lazy loading, you'll probably have to just have a placeholder with a loading indicator or a spinner or something like that that is still not going to show the actual UI that the user needs to engage with. With incremental hydration, you can render part of the page on the server. For example, the sponsored recommendations here in this web app here. They are at the very bottom of the page. And very likely, the user is not going to engage with them immediately. But at the same time, we may want to render them, so whenever the user scrolls to the bottom, they see them. However, in order to lazily load this JavaScript and download it and hydrate this part of the application only when the user needs it, we can use incremental hydration. And here is how it works. Pretty simple, actually. So first, here, we're just using hydrate on viewport, where we are rendering the recommended products, and we can even prefetch on idle. That's it. You pretty much need to wrap your page, your rendered content in the for block. If you want to learn more about all these features that we shipped, you can check the talks by MINKO and Brigada on server-side rendering in version 20, and also Angular's hybrid rendering, and when you should be using different hybrid rendering strategies, different rendering strategies for your pages. All right, so finally, testing. Over the past couple of years, we have been looking for good replacements for Karma because it got deprecated. And we evaluated Jest, Web Test Runner, and we shipped experimental support for them over the past years. With Jest, we mostly invest in it because of its community adoption, but it had some major missing features, such as browser testing. We believe that if you're building web applications for the browser, you should be able to test them in the browser. And recently, since we introduced this experimental testing test runners, we saw how vtest just took off. And it grew a lot in adoption and functionality. So as part of version 20, we now have experimental support for vtest that includes browser testing as well as watch modes. We haven't decided on the default solution that we're going to move forward with. Our intuition is saying that it's probably going to be vtest, but if you have other thoughts about it, just please give these test runners a try and let us know on GitHub. Help us just make the decision for what is going to be the future of testing in Angular. There is a talk on testing later today as well by Rainier about the art of testing, so make sure you check it out. Now let's chat a little bit about developer experience. I bet many of you have had to do some performance profiling in your apps just to see what is slowing you down. And historically, you have been able to use Angular DevTools. Let's look at it actually and profile an application. So if you would like to see what is going on in this application, you can open Chrome DevTools. You can go to the Angular tab. You can click on Profiler and start interacting with your application. And you're going to get the change detection cycles as they occur. And when you click on a particular bar, you'll see how much time you're spending in the individual components. And that is somewhat helpful to identify immediate performance issues in your app. One missing thing here is seeing how this change detection cycle, how they happen within the context of the main thread in your browser overall. So as part of Angular version 20, we worked closely with the Chrome DevTools team and developed integration between Angular and Chrome DevTools with a performance track that is specific for Angular. So if you go to the browser, open DevTools and type enable profiling in the console, you enable the hooks that Chrome is using in order to visualize Angular-specific data in DevTools. Now, when I start recording, can I start engaging with the application? And I should start recording, actually. And I stop the recording. I will be able to see this Angular custom track directly within the context of the application's execution. So when I zoom in, we'll see how we're spending our time in the application. For example, running change detection in the app component. And we can see the main track with the flame chart right underneath. So significantly more helpful but also for more advanced use cases. So now you have the choice whether you need to use Angular DevTools or Chrome DevTools. Entirely depends on your use case. More advanced use cases, most likely Chrome DevTools. In version 20, we also ship support for deferrable views in Angular DevTools. So whenever you have a defer block, you'll be able to see it directly within your component explorer. And whenever it gets triggered, you will see the components that it actually renders in its component subtree. Now let's chat a little bit about the style guide. I mentioned to you the story of how I created my initial draft of the AngularJS style guide back in 2013. Since then, we created a style guide for Angular in 2016, and now we updated it in 2025. The initial style guide, I drafted something, Todd Motto and John Papa created their own versions, interpretations, and created like a beautiful, really well-developed style guides that the community adopted. And at that point, we had 3 different style guides, 3 different ways to build Angular apps. The Angular team noticed that, and for Angular version 2 back then, they wanted to have one consistent way to build apps. And that's why we joined forces, and we created the official Angular style guide. One challenge there was that Angular was not even released at that point. So we had to gain inspiration from AngularJS and project how people will be using Angular in order to create the style guide. We did pretty well, though, because we didn't have to update the style guide for close to 10 years. And now, in 2025, we revisited some of the best practices that we defined, and we created the latest iteration of the style guide. Jeremy Elborn from the Angular team spearheaded that effort and ran an RFC to help us include the community so we can get more feedback. This is also a recursive process in a way, or at least iterative. So we create a style guide and we improve it twice. The latest iteration mostly contains simplification, so we removed some unnecessary practices and we updated some obsolete practices as well. And probably the most controversial change that we introduced in the style guide is around naming. Remember that we have component suffixes. People were really dissatisfied that we actually recommended that we drop them. Our goal here is mostly to just let you be more intentional about your component naming. See, user.component.spec or user.component doesn't carry as much semantics. However, user profile card tells you what exactly this component does. Still, though, if you're feeling opinionated and you don't want to use this naming, you can configure schematics and preserve the suffixes. We also updated some obsolete practices, as I mentioned, specifically around host bindings. So historically, we've been using host listener and host binding, and they have an advantage that you can put them directly on top of kind of the logic that you'd like to be invoked whenever something happens in your app. And also, they had slightly better IDE support compared to the host bindings in the directive metadata. In directive metadata now, you can declare identical functionality, and that's actually what we decided to move forward with, because it is significantly more compact syntax, doesn't use decorators that are just more complicated overall, and makes everything just co-located. And at the same time, we introduced better better IDE support that now allows you to have auto-completion, syntax highlighting, and type checking directly within these expressions. The last part of version 20 is zoneless. So in zoneless, we want to enable you to create Angular applications without using Zone.js. And we're close to be done with it. In version 20, we shipped developer preview of this feature, and you can already start using it, actually. I'm not anticipating any major changes. First, you can just bootstrap your application with provide zoneless change detection, and right after that, take the shortest and simplest path, you can change your components to one push change detection strategy so that they're already zoneless compatible by default. From there, you can use signals for managing local component states so that you can notify Angular whenever something changes. All right, that was the overview of Angular version 20. Now let us talk a little bit more about Angular in 2026. Even though you already got some preview, likely in version 21 or in 2026, we're going to ship stable Angular zoneless, and we're going to have the resource API and developer previewer stable too. But there are some bigger changes or bigger improvements that we're planning in the next year. The first one is us revisiting animations. We created Angular animations back almost 10 years ago when CSS was significantly less powerful. The web animations API was significantly simpler and plainer and not as expressive. So with the changes in animation, we're aiming to improve flexibility, simplify the API surface, and modernize Angular. An alternative animation approach that we're considering currently and we're likely going to move forward with after running an RFC is with these primitives, in and out. That's pretty much the whole API without defining a custom DSL. Here, for these components, you can specify a CSS class that is going to be applied whenever a particular component enters the view, and out, well, whenever it leaves it. You can also specify custom animation functions, so you can use your favorite animation library directly with Angular, instead of having to use a custom language that is only Angular specific. Again, this is just an early preview. We haven't finalized even the naming of these in and out. It's small API, but we're going to collect feedback from folks and run an RFC before we finalize it. Now let's chat a little bit about signal forms. In Angular, we've been having two different ways to build forms: template-driven and reactive forms. We've received feedback about both of these approaches that they don't scale too well and they're a little ambiguous. So something that we have been thinking about is how do we update the signal story together with the reactivity model? And we've been prototyping, very early prototyping, approach for forms using signals. And here is a very early preview of it. It is still very early prototype, so just expect major changes. You can declare your reactive state in a signal, and from there just use the form function in order to declare the validation of these individual fields. This is all reactive and signal enabled. Another change that we have been thinking about is selectorless. And remember that none of these changes are really abstractive. They would enable you to have better developer experience incrementally, and many of them are going to come with automatic code transformations that I'm going to talk about in a little bit. So historically, Angular has been enabling you to kind of define like a dynamic scope. So for example, in right here, we are importing the map button and the tooltip once within the TypeScript file, and after that, we're importing it within the app component. This seems like a duplicated import. But the power of it, in a way, is that if you import different components that match the same selectors, you can get different behavior. However, in order to do that, well, you have to update your TypeScript file to import the different primitives. And really, nobody does that right now. So you have this duplicated import without too much benefit. We have been thinking about an alternative approach which allows you to directly import the map button and the tooltip and apply them within your template directly with a single import without this code duplication. I mentioned the aspect that it is going to allow you to write cleaner code, but it's also going to make Angular faster. Because if we go to the previous example, here we'll need to do one round of selector matching. We'll need to see which selector does exactly map button and tooltip match within the template. We'll no longer have to do that with selectorless. So we'll not have to ship this code as well, which is going to make your applications load faster and is going to make them smaller. And last but not least, it's also going to enable faster compilation. Because every single file in your application will be able to be compiled independently from the rest of your app. So your compile times, your build times are going to get faster with selectorless. Now, thinking about component authoring, we have been thinking how we can further improve authoring experience if we had to. This is very early brainstorming, so nothing specific, and we don't even have prototypes of that. But just wanted to let you early on that we're thinking about how we can make your developer experience smoother. We have been exploring whether function components may make sense for Angular, whether single file components make sense for Angular, whether we should enhance further the class syntax. As we make progress here, we're going to share updates with you. And just remember, these are just ideas. We just want to consistently think about how we can make your developer experience smoother. So I mentioned to you also that I've been using Angular and involved in Angular for a while. And one thing that I've been missing is kind of having like a small symbol or a mascot that represents Angular to use as a plushie or a keychain or something. So after years now, we joined forces with the creative minds behind the Flutter and Go and the Firebase mascots and developed a couple of prototypes for Angular mascots. You have probably seen the first version of the mascot that we proposed as, in your Angular t-shirts that you received today. The designers looked at what Angular has been up to over the past years, looked at our strengths and weaknesses, and came up with these 3 different variations after many iterations. We run on RFC, actually, which is already our most popular RFC, as you can imagine. We have like over 1,000 votes for these, and you can cast your vote as well online. And before you ask, we had banana in a box as one of the mascot concepts at first, together with the Phoenix. Currently, the Angular-shaped character is winning, so if you like the Angular fishes, or fish, make sure you go to the RFC and comment there. So I've been looking at my timer here, and I saw that for the last 27 minutes, I didn't mention AI a single time, which atypical for a conference nowadays. At the same time, though, AI has been really making like groundbreaking changes in our developer experience and also in the user experience that we built for our customers. So as part of Angular.dev/AI, we shipped some guidance on how you can include Gen AI to your applications with GenKit or Vertex AI, and also how you can enhance your developer workflow by using AI. I've been using some dev tools myself, like I've been using Cursor, I've been using Copilot, Firebase Studio, and I've been really getting like increasingly more productive with them. Like they just eliminate the boring tasks that I don't want to deal with. And usually when you use AI to enhance your developer workflow, you either use some agents or just faster code scaffolding and code generation. And for scaffolding and code generation, you use whatever the LLM is powering this functionality. So the large language model is going to generate code for you based on the code that it has already seen from other sources. And Gemini, together with other models, has been trained on public resources, mostly on GitHub. And as you can imagine, like most of the projects on GitHub, they're not keeping up to date with the latest versions of Angular, right? Like you have variety of versions all the way from version 2 to version 20, and Gemini has seen all of it. And it's really hard for Gemini to distinguish what is a best practice and what is not. I'd say the vast majority of the code that Gemini has seen is not the latest best practice. So how do we make sure that Cursor or Firebase Studio always produces code that follows best practices and uses latest APIs? Well, there are 2 main general ways. We can fine-tune the models that we're using if we're using local models, but this is a pretty flawed approach. First of all, it's expensive. Let's suppose we want to fine-tune Gemma. We'll need to run thousands of compute hours, and we'll have to pay for it. And just right around the time when we're done fine-tuning this model, well, Google is going to ship a new version of Gemma that we need to fine-tune as well. So something that has been the more viable solution lately with the large language models with large context windows is to provide extra context. It is significantly simpler and produces similar results. So what we do there is just add a system prompt, just a bunch of text explaining what the model needs to generate and providing it as part of rules or as part of the system prompt. In order to make sure that your AI-assisted tooling is producing code with best practices, you can always use rules files that we directly provide for you on Angular.dev. So head out to angulardev/ai/develop with AI and find rules files for Cursor and Firebase Studio, and also a generic rules file that you can use also with GitHub Copilot and others. From there, we'll be continuing to fine-tune these and updating them for new versions of Angular. We'll be also working with authors of these tools to make sure that they're part of the base experience over time. But another area that we have been looking into is code evolution. I mentioned some changes in this talk, right? I talked about signal forms, talked about animations, talked about selector lists. Over the years, all these changes in Angular, well, we have been very intentional about them. If you have learned Angular version 2, you'll likely be able to use Angular version 20 as well with some small changes. And for the updates that we can, which are, I would say, most of them, we shipped deterministic AST code transformations with schematics. So if you don't want to use ngIf anymore and you want to use the new control flow, you can just use the schematic. There are, however, some changes that are not as deterministic. If you would like to update from the old form system to the new form system, well, we can't really do that with schematic. There are just too many edge cases, and the API is just too big. However, LLMs are really great at that. So for non-deterministic or less deterministic tasks, that's where we can leverage AI. That's an area that we have been exploring as well. Overall, our focus has been to make sure you're as productive with Angular as possible, and we keep your code up to date with the best and latest best practices. So after all of this, my call for action is just to go and run ng update in your projects, get the latest version of Angular, and from there we're going to keep evolving your projects incrementally. And again, like us improving Angular, it is a recursive process. We just keep looking at the current state of the world, and whatever the business needs right now, we try to incorporate in the latest features for performance and developer experience for the framework. And even though it looks like the old cozy framework, we keep improving it and polishing it again and again. Thank you all, and hope you enjoy the rest of the conference.